You know that feeling when you're looking at a huge to-do list for a new project and you have absolutely no idea where to start? It's just chaos. Well, that's exactly what we're going to tackle today. In this explainer, we're going to break down how to turn that whole mess of tasks into a clear, logical, and most importantly, actionable project timeline. Okay, so we're going to do this in 5 simple steps. First up, we'll define our goal, like what even is a project schedule? Then we'll drop a visual blueprint for the whole project. After that, we get to the fun part, a little bit of maths to figure out the earliest and latest dates for every single task. And finally, we'll put it all together and see that finished schedule come to life. All right, let's dive right in. What are we actually trying to accomplish here? And why is a schedule just so critical for any project to succeed? I mean, this is the fundamental question, right? Think about building a house for a second. You can't put the roof on before the walls are up, and you're definitely not putting up walls without a foundation. It's just impossible. Well, every project is exactly like that. It's just a series of steps that depend on each other. So the real challenge is, how do you map all of that out so things happen in the right order? And the answer, of course, is the project schedule. This is our master plan. And listen, it's way more than just a to-do list. It's a detailed map that shows who's doing what, and, this is the crucial part, when they're doing it. It gets the whole team, all the resources, and the entire timeline on the same page. It's that single source of truth. So, this right here, this is our end goal. A simple, clear bar chart, you probably know it as a Gantt chart, that maps out the entire project. But what's really interesting is, how do we get the information to build this, with any real confidence? Well, it all starts by creating a blueprint of the project's workflow. Okay, so let's get into it. Let's build that blueprint. Before we can even think about that final bar chart, we have to find a way to visualize the project's workflow. We need a map of every single dependency. And the way we do this is with something called a precedence network. Now, that might sound a little technical, but the concept is actually super simple. Basically, every single task in the project gets its own little box, or node, and then we just draw lines between them to show the dependencies, which tasks have to be finished before others can start. Now, you can't just start drawing boxes and lines randomly. There are a few key rules for building this map. For one, time always has to flow from left to right, from one single start point to one single end point. But really, it's the next 2 rules that are absolutely critical. They're what stop your whole plan from collapsing into, well, logical chaos. Rule number 1, no loops. A loop, like you see here, is basically a project paradox. It's like saying, okay, to get your keys, you first have to unlock the car. It just doesn't work. It's a completely impossible sequence that gets your project stuck forever. And rule number 2, no dangles. A dangle is basically an orphan's task. You see it right here. This task is just left hanging. It's not connected to the project's finish line. And you have to ask yourself, if a task doesn't connect to that final project complete milestone, then why is it even in the plan? Every single activity has to lead to that end goal. Okay, so once our visual map is drawn correctly, no loops, no dangles, all the dependencies are clear, we can start putting some numbers on it. This is the point where our blueprint really starts to become a schedule. So the first bit of math we do is called the forward pass. And honestly, it's exactly what it sounds like. We're going to move forward through the network, from the start to the finish, left to right, and calculate the absolute earliest date each activity can possibly start and finish. All right, let's actually walk through this. On the left, you've got our basic map. We always start a project at day 0, right? So look at the top path. Task A takes 6 weeks. Simple enough? So its earliest finish is week 6. That means task C, which can't start till A is done, has an earliest start of week 6. Make sense? Now look at the bottom. Task F takes 10 weeks. Its earliest finish is week 10. Okay, now here is the most important rule of the forward pass. When multiple tasks feed into one, like they do here for task H, you have to take the latest finish time as your new start time. Why? Because you have to wait for all the previous work to be done. We just keep applying that simple logic all the way to the end, and that gives us the earliest possible finish time for the entire project.
So that's huge. We now know the absolute earliest this project can be finished, in this case, 13 weeks. But that's only half the story. To build a really smart schedule, we also need to know the latest each task can finish without completely blowing that 13-week deadline. We need to find our wiggle room.
And to find that wiggle room, we do what's called a backward pass. It's the mirror image of what we just did. We take that earliest finish date,
13 weeks, and we make that our non-negotiable deadline. And this time, we work our way backward through the network, from right to left, subtracting the time for each task. Let's trace this one backwards too. So our hard deadline is week 13. Look at task G, it takes 3 weeks. To finish by week 13, it absolutely has to start no later than week 10, right? 13 minus 3. We just keep subtracting our way back through the whole network. And just like before, there's one key rule. When you're going backwards and a task splits into multiple paths, you have to take the earliest of the latest start times. This whole process gives us the latest possible date every single task can start or finish without wrecking that final deadline. And that's it. The hard part is totally done. We've done our forward pass, we've done our backward pass, and now we have every single piece of data we need to build our final and really smart schedule.
This, right here, is the magic of the whole process. Think about it. For every single task, we now have 2 sets of dates, the absolute earliest it can start and finish, and the absolute latest it can start and finish without delaying the whole project. That gap between the earliest and the latest, that's your float. That's your wiggle room. And you'll find some tasks have 0 float. They're on the critical path, meaning they cannot be delayed, not even by a day. But others might have days or even weeks of float, which gives you incredible flexibility.
And look at that. We've come full circle. That abstract network diagram we spent all that time on, with all the boxes and lines and numbers, it transforms directly into this, a practical, easy-to-read bar chart. Each bar is just plotted on the timeline using those earliest start and finish dates we calculated. And just like that, we have a real, data-driven schedule.
So, if you take one thing away from this, let it be this. A solid schedule isn't a guess. It's not just random dates on a calendar. It's a calculated plan built on a logical blueprint. By figuring out the earliest and latest dates, you're not just creating a timeline. You're uncovering where your project is flexible and where it's rock-solid critical. But of course, that leads to the next big question, doesn't it? It's great to have a plan, but what do you do when things inevitably go wrong? That's a story for another time. Thanks for joining me.